So number 102 is a red level problem. We've got a 49 kilogram rock climber is climbing a chimney. The coefficient of static friction between her shoes and the rock is 1.2, and between her back and the rock is 0.8. She has reduced her push against the rock until her back and her shoes are on the verge of slipping. A, draw a free body diagram of her. So in this case, we actually have 2 points of contact. I'm going to draw a free body diagram for both of them. So and this is interesting. The normal force of her shoes, or of the one rock face on her shoes, is equal to the normal force of the rock face on her back. These two are equal, and if she increases her push, both of those will increase at the same rate. They have to be equal. These are the only two horizontal forces acting on her. Vertically, we've got the force of gravity. So if you take 49 times 9.81, gives you about 480 newtons to 3 sig figs. And then we also have the force of static friction. It's static friction because we know she's not sliding. Please note that these will be two different values. Even though the normal force is the same, the coefficients of friction are different between the two sides. Again, remember, between her shoes, it's 1.2. Between her back, it's 0.8. So, B asks then, what's the magnitude of her push against the rock? Well, what do we know has to be true? Well, we know the sum of the two static frictions have to add up to the force of gravity on her. The vertical forces must add up to 0. The force of static friction can reach a maximum value of mu times the normal force. In this case, we're told she's on the verge of slipping, so we'll assume that it's right at that maximum possible value given that normal force. So in this case, the sum of those two must equal 480. The normal force is the same on both of those. So you can very quickly add those together, get 2 times normal force is equal 480, or our normal force then, this is the answer to B, must be 240 newtons. Question C asks, what fraction of her weight is supported by the frictional force on her shoes? To do that one, we're simply going to calculate the force of static friction on her shoes. Remember again, the coefficient of static friction is 1.2 from up above, and the normal force we just calculated is 240. And so we get 288 newtons of the total upward frictional force is provided by her shoes. What fraction is that? Well, if we take that 288 over the force of gravity, it gives us exactly 60%, which is also the ratio of that friction over the total, 1.2 out of the sum of those, which is 2. And that is the answer to this one.